Okay, so this is part 2 of looking at the reactions of the sodium halides with sulfuric acid. In the previous video we looked at the reaction of sodium chloride with sulfuric acid, and because chloride ions are not strong enough reducing agents, they will not reduce the sulfuric acid, they will just react with the sulfuric acid where the sulfuric acid acts as an acid, by which I mean it donates a proton to the chloride ions, giving you white fumes of hydrogen chloride gas. All of the sodium halide ions in question will do exactly the same thing. They will produce the hydrogen halide gas. They will also produce the sodium hydrogen sulfate, and this hydrogen halide gas will react with ammonia and it will give you the ammonium salt. Okay, and that is a white solid. All three will react in the same way. However, sodium bromide will continue to react. So sodium bromide ions are, as we go down the group, so this is down the group, bromide ions are bigger than chloride ions, and therefore the valence electrons experience weaker forces of electrostatic attraction, and so they can lose that electron more easily. The ability to lose an electron and give it to something else makes something a better reducing agent. So let's look at how sodium bromide, let's look at, so by this point we've had, oh yeah, all right, hang on, NaBr plus H2SO4 gives you, oh sorry, God's sake, right, HBr plus NaHSO4. Okay, this will then go on to react with more sulfuric acid, and it will give you bromine plus sulfur dioxide plus some water. It's going to give us two waters because you've got SO4 there and SO2 there, so let's just balance our hydrogens. We need two there, and then that takes care of balancing our bromines. Okay, so that's the overall equation. Most commonly you will be asked for the ionic equation here. So let's start with what's happening with our bromine, our bromide ions becoming bromine. So we've got 2 Br minus, and that is becoming Br2. It has lost electrons, therefore we need 2 electrons on that side. Okay, so our bromide ions have been oxidized because they have lost electrons, so oxidized, therefore they are acting as a reducing agent themselves. Okay, so that's our bromide half equation. Then we've also got sulfate ions. So we've got SO4 2 minus, and that is going to become SO2, sulfur dioxide. Now we need to do some balancing here, not just with electrons. We've not got our atoms balanced. Sulfur is balanced, that's fine, but oxygen is not. How do we balance oxygen atoms? With water. So we're going to need 2 H2O on this side. Okay, so we've got O4 there, O2, 2 H2O. How do we balance our hydrogen ions? Well, we're going to need on this side 4H plus. And now we need to finally balance our charges. Once our atoms are balanced, we've got 4H plus on this side, 2 minus, so an overall charge currently on this side of 2 minus, overall charge on this side of 0. So we're going to need another 2 electrons on that side. So our sulfate ion here has been reduced, it has gained electrons, therefore it itself has acted as an oxidizing agent. Okay, let's just check that that does work. Let's look at our oxidation states here of the sulfur. So O4, remember oxygen and oxide ion, unless it's in hydrogen peroxide, has a charge of -2, and there are 4 of them, so that's -8. With an overall charge of 2 minus, means our sulfur there must be +6. On this side we've got O2, so 2 times 2 minus is 4 minus. That's overall is neutral, so that must be plus 4, and that works. It's gained 2 electrons to go from plus 6 to plus 4. Therefore it has been reduced by our reducing agent. The other thing that you need to know about this, I just shimmy up a little bit, is what your observations will be. Okay, so if we had sodium chloride, the only observation we're going to get is those white fumes and the white solid. If we had sodium bromide, well, we're going to get, first of all, a choking odour, and that is from the sulfur dioxide. The other thing that you will get is if you add to this mixture, if you dip in some potassium dichromate paper, then it will turn green. Goes, and I actually happen to have a green pen here, so I'm going to use it. Goes green. Okay, so that tells you that you have not got sodium chloride. Okay, the other thing that you might observe, and if we just come back to this one here, sodium chloride, so gases, you're going to have HCl. Contents of the test tube, so white fumes / solid. You're not going to have any other gases there. Sodium bromide, you would have HBr. You would also have some SO2. Contents of the test tube, you might see kind of orangey brown, and that is from the fact that we're making some bromine. Okay, so now we can, we've talked about our observations, we've done our half equations, we can combine those, which you could be asked to do. You could be asked to give the overall ionic equation. So 2 electrons, 2 electrons, so no balancing required. I'll do the overall one down here in red. So we have got, where are we, 2Br minus plus 4H plus SO4 2 minus. Electrons cancel out, and that gives us SO2 plus Br2 plus 2H2O. Nothing else can be cancelled here. We don't have any waters on this side. We don't have any hydrogen ions on that side, so that's our overall equation. Okay, right. The third and final sodium halide that you need to know about, does that work? Yeah, is sodium iodide. Just to go back briefly, that is as far, bromide ions are decent reducing agents, but they're not as good as sodium iodide. So this is as far as that reaction will go. So if you get white misty fumes and a white solid, that doesn't really tell you anything. It tells you you've got one of these three. If you also get a choking odour and potassium dichromate paper going green, that tells you that you don't have that, but you could still have either of these, because sodium iodide will do exactly the same thing. It will produce that plus iodine, which is a different colour, I grant you, but nonetheless you'll still get the choking odour and potassium dichromate paper going green. If you produce iodine, you will also get a grey-black solid, or you could put purple vapour. You cannot put a purple solid. Okay, the vapour is purple, the solid itself is grey-black. And iodine, of course, as you go down the halogens, they get increasingly dense and darker. So bromine is a liquid and iodine is a gas. Right, so let's have a look then and see what sodium iodide will do. So first of all then, it will react with sulfuric acid, where the acid acts as an acid, and it will give you, where are we, HI, gas, hydrogen iodide plus, always the same, NaHSO4. That will react with NH3 to give you the ammonium salt. That is a white solid, and that's the observations you will get. Iodide ions are good reducing agents, and so, that HI will continue to react with sulfuric acid, and it will give you, where are we, iodine, need 2 there, plus sulfur dioxide plus 2H2O. Exactly the same as before. I'm not going to do the half equations because we've literally just done them. They're exactly the same, except you've got iodine instead of bromine. You've got SO2 produced, which has a choking odour, and it will turn potassium dichromate paper green. Okay, now because iodide ions are really good reducing agents, they will reduce the sulfuric acid even further. Okay, so they will take it from sulfuric acid through to hydrogen sulfide, and they can even take it all the way through to just sulfur. Okay, so let's just have a look at that one now. Okay, where are we? So if we've got hydrogen iodide plus H2SO4, and sorry, it will produce hydrogen sulfide gas, okay, plus we've got SO4 here, so we're going to need 4H2O, and sorry, just bear with me 1 second. Just want to check, is it lead ethanoate paper? Lead ethanoate. Okay, yeah, so where are we? Oh, the iodine, right. So we've also got I2, okay, because obviously it exists as a diatomic molecule. Our hydrogens aren't balanced. We've got H2 there and 4H2 there, so 8 and 10. So H2 there means we need 8 over there. So we're going to have 4 I2. Right, now we will know that we have produced that, okay, because, and this green probably isn't helpful here, it will turn something called lead ethanoate paper black. Okay, lead ethanoate paper will go black. It also smells like rotten eggs. Lovely. Right, let's just do the ionic equations for that. Can we still see? Yeah. So we've got 8 I minus going to 4I2. In fact, I'm not going to do that actually. I'm just going to start very basically. Sorry. This is, okay. With I minus going to I2. And I'll put 2 there plus 2 electrons. Then we've got our sulfuric acid half equation. So SO4 2 minus going to H2S. So we've got, we need to balance our oxygens. We don't have any oxygen in here, so we need 4 H2O, and then we need to balance our hydrogen ions, so we're going to need, where are we, so we've got 8 there plus the 2 there, so we need 10. Okay, so 10 of those over there, and on this side it is neutral. On this side we've got 10 plus and 2 minus, so we need, can you see that? Yeah, so we need 8 electrons. Now we can see that obviously this isn't balanced when we come to combine them, so we're going to need to multiply that by 4. Where are we? Yeah, we need to multiply that by 4, and there's already 2, so that gives us our 8 there, and our 4 there, and our 8 there, which means we can now cancel those, and that gives us our combined equation of 8I minus plus 10H plus SO4 2 minus, where are we, gives H2S plus 4H2O. Okay, that has a rotten egg smell, as we've already said, and it will turn lead ethanoate paper black. Now, it will go one further than that. in that it will reduce all the way to just sulphur. So we've got hydrogen iodide plus sulfuric acid will give you iodine plus sulphur plus H2O. Okay, so you're always going to get your halogen, some water, and then either sulphur dioxide, hydrogen sulfide, or just sulphur. So we need to balance that. So SO4, so we need 4 there, and then we need, where are we, 4 H2O, and we've got 2 there, so we've got 8, so we need another 6, and then we're going to need a 3 there. Okay, so that's your overall equation. And then we can do our half equation, so just starting with iodine, going to iodide, going to iodine, and then SO4, 2 minus, going to S, and we need to balance our oxygen, so we need 4 H2O, which means on this side we need 8 H plus, and then we need to balance our electrons, neutral on this side we've got 2 minus and 8 plus, which means, where are we, overall, hang on, what do we need, 6 electrons, is that right? Yeah, plus, yeah, 6 electrons. Okay, so we need to times that one by 3, so that gives us 3, where are we, 3, oh, idiot, right, 2i, so we had 2i minus to start with, multiply that's going to give you 6, and then that's going to give you 6, which we can then cancel out, and then we can combine, so 6i minus plus SO4 2 minus plus 8H plus gives 3I2 plus sulphur plus 4H2O, okay, which is the ionic version of that. And that sulphur is, can you see here? Can you see that? Yeah, is a yellow solid. Okay, so that's the overall equations, that's how to do the half equations, that's how to combine the half equations, and that's the observations that you would see for each of those reactions. So when you then come to do or have a look at this sheet and you're looking at the answers, hopefully this will now make a bit more sense and you can answer those questions, and then worksheet 8 you can hopefully have a better stab at as well. Okay, all right, bye.